Welcome. Sorry for the longer start. The guys, the other speakers told me that the audience here is pretty technical, not that business oriented as my presentation is prepared for. So we will just quickly skim through the first part, then I'll take you through the examples of the AI applications, and then we'll probably have some time for live demos. My first question is, do you know Kebula here? Who loves Kebula? Okay, who knows Kebula? Who hates Kebula? uh, that's just because I'm gonna skip through all our buzz hype bullshit and real meat in the beginning. The agenda is why and how. That's about Kebula, and those other topics will be about AI apps. So let's skim fast through the bullshit. Um, the rise or growing amount of data all around us is evident or obvious, and it has implications not just for Kebula but for everyone, every company, and it's getting worse and worse every 3 years. I think it's the triple the amount every 2 years or something like that, and it's not stopping at all. Um, uh, One more thing which already happened is that even the people from business want to work with data or interact with data, not just the guys from the IT or data teams. So there's new role coined by Gartner called business technologies, with someone who is able to at least use data or AI in his daily work. Skipping manual data stack. Uh, this is just example how it could look like in a large company, like 12 to 50 components or building blocks connected together, being called a data stack, where are too many point-to-point integrations, and it's just great. It brings lots of money to the cloud providers and to the consultants and to everyone, but not to the company, which we believe Kebula is changing already. And the thing is going to be even worse with the AI, because so far just the people were accessing or using the data, or um, uh, uh, pretty well-defined systems were communicating with each other, and now there's the AI with its random questions, random API calls, and chain of thoughts trying to gather data from different systems, which will even more put even more load to all those broken stacks in the back. Oh, oh. So this is our claim. Actually, it really happens. Kebula brings. I don't know if it's every time 10 times growth in the productivity, but at least 2 times. I would say it's a norm, because most of the work on top of the current stack is taken away, and you just focus on your analytics, your data cleaning, your data processes, etc. And one thing we are aiming at is that we want to make it like 40 or 50 with the AI. And the inspiration comes from GitHub Copilot, where their claim is that I think that 40% of commits of the users with Copilot are committed without changes, which means that they might be much more productive. And what we want is to adopt and put this easiness of usage or AI help or AI assistance to Kebula. Skipping, and that's it. So that was like why you should love Kebula. This slide is about why do we think that building AI apps and leveraging the power of LLMs or generative AI makes sense the most in our platform or in similar platforms, or if not the most, then very much. And the thing is that AI works with data or with your applications, and that's the place where you have it is Kebula. So it's logical to connect all these things inside one platform, keeping like management, governance, all that stuff in one place. So that was the bullshit in the beginning, completed. And now the real examples. We have a Docsbot, call it Docsbot, like everyone was playing with some sort of chatbot on top of documents or whatever in last couple of months. And we started the same, like, I don't know, 3 months ago with Rohlik. They have pretty old or pretty it's not old, but the API of their knowledge base is creepy, says nothing, slow, cannot search, like unusable. It can just export the data in some shitty JSON, and they have thousands or maybe tens of thousands of articles describing who should I ask to get a vacation, how to ask for something for my desk, or how do we treat delayed orders, whatever. Everything is in their knowledge base, and searching for it in the tool itself, it's pain. So we've prepared a Docsbot, which helps them ask questions and is integrated to their Slack. They were doing the same at the same time. They started building it with NVIDIA A100 cards and training some Llama Alpaca models. But at the end, we both ended using LangChain and some chain of thoughts and vector database storage, where there's some logic for the bot, and the rest is just about retrieving the relevant information from the vector storage and answering to the user. It happens in the Slack, and in the Slack we also collect the feedback. So how does it work? The user enters a specific Slack channel, asks a question, gets some answer, and for the answer, the bot is also disclosing the sources from the knowledge base where it found that information. There are three states of the feedback. One is great, thank you, works. The second is no, this is not right, this is wrong, didn't help, not true. And then the third one is correctly answered as of the information in the knowledge base, but the knowledge base is wrong. We have an example. One of the guys were asking the bot where do they have their headquarters in München, got address and map, but the knowledge base is like 1 year old information about the headquarters. So without WhatsApping the rest of the team, if it's the correct address, he would end up somewhere like I don't know where. So three states. It's not just right and wrong answer, but bad data. Right answer based on bad data. That's it. And what we are working on right now is to let the bot, let's say, be up to date. We are extracting data from their legacy Tetra knowledge base, adding some more articles from Jira or specific projects in Jira and Slack channels, then clean the data, feed it as JSON documents to the vector database, and that's it, because the bot is connected to the vector database. So once we update the vector store, it's updated, and the bot knows about the new stuff in the documentation or knowledge base. That's it. Okay. Yeah. Details. And then we have a SQL bot, which is created in cooperation with Česká spořitelna Erste. They have a team of lazy data engineers or data analytics, or not just one team, plenty of teams of lazy data engineers and analytics, and they are being taken from their flow by not really stupid but repetitive and very simple questions from other business users, and they need to go to their pretty well prepared data mart or one big table or super table and just ask that stupid question and answer it to the business user, because it's maybe not in a dashboard or not in a report, but or the user cannot find it or the analyst cannot find it. So from time to time they have such requests. It's like for everyone, it was more than 10 times a week. So they can bet that every day someone asks such question, and this is where the SQL bot comes in and helps. Our aim is to not have a SQL bot as part of Kebula, and everyone will be using the same SQL bot. It's basically a boilerplate where you can connect your bot to your data and give it hints about what does the data mean. Give it, let's say, markdown documentation of those tables in the data mart or that big super table. And as the bot has enough information and has is using a long chain tool for querying SQL databases and reasoning how to query a database, works pretty well. I want to show you a demo in the end. No, I don't see what's the last one. Contract bot. I don't have a demo for contract bot, but we have a, Apify. Anyone know Apify? Mavericks. Mavericks is a lawyer firm taking care of startups and scale-ups and all the new companies, focusing on term sheets, contracts with between founders, and all that stuff. And they had an idea to build a term sheet bot, which will basically allow you to send your term sheet as a founder and get a result if it's a ripoff or good stuff. And if you ask a lawyer for it, you will pay, I don't know, hundreds of bucks at least. So this should be for free, and they want to have it as their, let's say, PR. They are super modern agency using the AI for themselves and for their customers, which the goal seems easy, and currently we are, like, let's say, in the middle of the development. And what is looking quite well is that even though the LLM models are not able to crunch large amounts of text because of their context windows are limited, then the documents can be cut it into chunks related to separate parameters, like how many investors are in the company now, who's coming in, how many tranches or rounds of the investments are coming, what are the dates, and if those specific questions have to return just the number of trenches and a specific dates of those trenches, it works pretty well. So the goal is to have, I don't know, it's like 70 specific prompts for specific for extraction of specific parts from the document, and that's the job of the AI. At the end, there's going to be JSON with just structured information about the term sheet, and then there's going to be Python code just evaluating it and saying, yeah, this is good one or not. So the logic of the evaluation is still outside of the AI. The AI serves just as a parser of a unstructured document with plenty of options to help. So that was what I have in the memo. This is what I don't in the presentation. This is what I don't have it in there. Impact analysis could be one of the things which would sound familiar to you. Someone is using a dashboard and someone is building the data underneath, and the guy, the data engineer building those pipelines, doesn't want to break anything down the stream. And impact analysis, uh, like historically, is done by having a lineage of every job in the platform and looking for what can be affected by those changes. And the data lineage is pretty complex stuff. While feeding all those lineage and metadata into LLM or AI application and asking questions like, what's gonna break if I change this, and getting the answer this, and this, or uh, a few things of Ota or a few things of Andrew will be broken, then you will just call Andrew or and Ota, tell them maybe this is gonna break you something. Check your stuff. So this is a help for the user to see what's gonna be broken by his changes, or for the user of the end report, he can ask like who's gonna and who's able to add me regions and I don't know, amounts to this report, and the AI can easily traverse the metadata and lineage and say, yeah, that's John and he's on vacation, so wait for Monday or something like that. We have a working prototype, still not ready for production because of the context window limitations. Once we ingest our huge multi-project architectures into it, it just fails to understand it. But we still believe it's doable. We just add some tweaks here and there to make it work. Other thing we are working on, and I will show you a short demo, is Prompt Lab, something for prompt engineers. Anyone knows who's prompt engineer? One, two. So the guy who is building the prompts is the prompt engineer, and those prompts can get very tricky. Like one word or just a different a slightly different sentence can lead to completely different results. And Prompt Lab is here to help the prompt engineer build those prompts, compare them between themselves and between each other, and see which one is the best, or maybe tune them more. I will show you a short demo. Then the AI generated pipelines. As we are adding more and more AI tools into the platform, like building a transformation. In Kebula, you can easily transform, like, I don't know, you have 3 tables, you want to join 2 of them and delete everything which is in the third one. That could be a simple transformation happening in Kebula. And if you know that you are going to do this, you will still have to write all the SQL code. And it can take you 20 minutes, maybe an hour, maybe half a day if you are junior. And for the AI, if you know the tables and are able to express your intent, the code can be generated. So this is something we are working on. If you know OpenAI Analytics, Advanced Analytics, I don't know how it's called. It was Code Interpreter, and now it's Advanced Analytics something, where you just push your CSV files and ask questions, and it starts thinking and generating insights, maybe actions from the data. So this is pretty similar. We will have the data which are coming into the transformation and have a short chat with you to build the code for you. Uh, and once we have those small pieces, then there could be one agent or AI just orchestrating all those together. So you might not sure if it was gonna work. Those small parts will work definitely, but if we take it a level up and ask you what's gonna the whole pipeline do, and you express that you are gonna collect data from there, then transform them and use them in uh, KPI report and your campaign optimization, it might bring you something which is close to it, and then let you just polish it there and tune it here, and or fix something, but not building it from the scratch. Uh, what we are building into the platform as a services is vector store and feedback store. Uh, uh, Vector store is obvious, and feedback store is there because all of the applications running in there should have one easy, let's say, SDK call or API call to put their feedback back to Kebula and let store it there for future improvements of any model. Uh, so that was the presentation. Any questions so far? Okay. So, and what I'm gonna show you, the first is our application, which is called, which is doing, not called, it's doing some SMS campaign generation. Um, the application or the flow takes data from Shopify, then transforms the data to some readable format, and then use OpenAI to generate. I will show you what. Basically, it just takes the data from the input and creates short description for SMS campaign, meaning the description of the campaign is actually the SMS message which is going to be sent, uh, and which is with informally addressed to the customer for product, title, description, body, and that's it. So as the data are cleaned up and customers eligible for a campaign selected, then the AI comes in and enriches the customer records with suggested message, which is then sent via SMS. And one more thing here is that it could be even approved before it goes out. So the campaign is, or the pipeline, AI pipeline is running every day, and all those messages are storing here. Uh, and just to show that it could be tweaked or approved, disapproved by the user, we've built the app to let you do so. So that was the first one. Then here's the Kai SQL bot. I've been asking how many branches can serve customers in German, which went well. Then I was asking about Brno, and it got exploded, which is something you should be aware that it can happen anytime. The AI isn't 100% perfect, 100% perfect, and never gonna be, or not in near future. But as we see it, helps like 80 or more percent times uh, to get you there. So what we have here is a streamed application which uses the AI LangChain as a backend, and have a few hacks here, which I can then talk to you about later in the networking session. I don't think we need to get into that much detail. The funny thing is that the whole SQL bot is just uh, I don't know, 86 lines of code, and then maybe a few Kebula specific packages, but the whole bot, that's it. So building your own and adding your metadata to the system prompts or to a vector store beside it, and letting the bot ask questions to the vector store, it's pretty easy. And then you can just deploy the application to Kebula and let your users use it. What I was gonna to show, yeah, prompt lab is here. I've been talking about the prompt lab for prompt engineers. The app is asking you to have your data stored already in Kebula, and then it allows you to run your prompts or challenge your prompts on top of your data. So we have a list of term sheets, and now we can play with some prompts. In the beginning, there's a prompt improver tool where I can ask or draft my prompt, like extract something like this, and the prompt or the tool uses all the OpenAI prompt best practices, builds an example where the array is correctly returned, and says this is the prompt. So I can use this one. And now we are in the second section where we can test prompts against each other. So my first prompt will be the enhanced one, and the second could be the basic one. Okay. I need to add the document there, and that's like super easy. I just use one column from the table, and give it as a document. So this should be it, and I want to test it on, let's say, five documents. I still can change the model used for the prompt, which I will change to GPT-16K, and for both. And also all the temperatures and other parameters of the models. So I can test the same prompt with different settings against each other, which could be also very interesting. Once I'm satisfied with the prompt, then I want to see how it performs with different settings or with different models. Now it's gonna take a while, and do I want to show something else, or this is just it? Yeah, that's it. So this is the last demo I have. Let's see if it fails or something. I should have chosen less than 5. Now we see that sometimes it works, sometimes it doesn't. What we have here is that we can download the prompts and check those responses for similarity, which actually gives you a comparison of the results between themselves. And what this leads to is that if you look at those which are very different, and if your prompt is very similar, then it means something. And what it does is that it brings you to some aha moments or wow moments when you just get understanding how the prompt should look like. What does the LLM wants from you? What you should put there and what should not be in the prompt. So this is let's say, your experimentation accelerator, not something which will save you and build everything, but makes you much faster when experimenting with all those slight changes in the prompts or adding bunch of examples in there, etc. And that's it.
Okay, thank you, Pavel. And now we'll move on to the questions. Let me just share my screen real quick. Okay. The first question is, how do you mitigate the errors you showed on DK demo?
You mean the SQL bot, probably. Um, as I was working with the example here, it's not very robust. And if you invest, let's say, a few hours into helping the robot understand the data, uh, giving them hints like, "Hey, all the tables are lowercase. Use lowercase and quotes, etc." Such a small stuff. It basically skips such dummy errors as I was showing on the demo. Then you get the interesting stuff, which is that the robot can get to sort of infinite loop, just trying to reason with itself, and ends in like consuming the limit for the request, and ends with an error or no information. Like it's gonna happen all the time. The mitigation is the satisfaction of the users with the rest of the results, um, and I think it's also about the UI. Um, we are using the it's called loopbacks, where we are showing the chain of thought of the robot. What is he doing? What is he thinking? Which helps the user be patient, understand if something breaks better, and not be just waiting for 7 minutes for a red error or something. So it's more about the UI. And on the other hand, whenever it works, the trust of the users is growing. They are not thinking, or they don't expect the robot to be perfect.
Okay, thank you. And the next question is, if you could describe the SMS usage case more in detail.
Yeah. Uh, the the information from Shopify is about the orders, all the orders, and basically there's also a segmentation running. So there's like a, lifetime customer value. Then you have the users with just one order, and they are not being in. They are filtered out from the campaign. Um, then users with specific products are grouped to segments. I'm not aware I can talk about the shop, but basically, if the user looks like a teenager, the message is gonna have emojis, etc. in it. If the user looks like a boomer, then it just sends him a fax or email. Like I'm making fun of it, but basically that's it. There are a couple of segments, couple of prompts, and each segment gets their specific prompt, and then it's just built from the let's say next best offer, which comes out from the transformation as a suggestion of next best product or products to be bought by that user, and then the segment of the tone of the message.
Okay, thank you. And then the last question before I let you go.
Mm-hmm.
How can I try the prompt lab?
Ping me. I think there's gonna be we are gonna be launching it probably this week. So the easy way is to start Kebula project, which should be for free. Like you get 120 minutes of processing, um, and prompt lab is already one of the templates, so you should be able to give it a spin right away. If not, ping me. It's like
Okay.
from
Thank
the
you.
morning.
Okay. Thank you very much.
Thank you.
If you have any more questions, feel free to ask later. And before I invite Jacek, let's have a 5-minute breather. So if you need to go to the toilet, for example, it's right behind the corner through the kitchen. And yeah, see you in 5 minutes. Okay, so next up is Jacek. He's partially full stack engineer here at Good Data, partially database wizard, and a developer advocate, as you can see. And he works in Good Data for roughly 9 years now. And his presentation will be about AI-powered BI solutions. Give a round of applause for Jacek, please.
Okay, so first of all, I would like to thank you that you attended in person. That's we really appreciate it, and you will be rewarded by food and alcohol in the end. Um, so my presentation actually won't be about engineering at all. It will be about end user experience, how we can leverage artificial intelligence for analyzing data. What should be the end user experience? I prepared this slide. Have you already seen this slide? Please raise your hands who already seen this. I would say that this is current artificial intelligence in a nutshell. Yeah. But some comments on this were, is it already conscious? It can change its minds in the middle of sentence. Actually, no, this is not true. It is still predicting the next best word, but because someone else already answered this way, so it predicted that this answer is the most correct. Yeah. And this is exactly the problem with current artificial intelligence. But seriously, what are the opportunities for analytics and business intelligence in the area of artificial intelligence? So as usually in Good Data, we started with some kind of discovery, which is actually a standard process how you should find new opportunities. For end users, we obviously first we analyzed the recent hype around artificial intelligence. What we can see currently on the market. So we can see end user experience, for instance, in a form of ChatGPT or Midjourney for images. We can see many natural language querying interfaces in all industries, including business intelligence. But as I will tell you a few slides later, nothing is production. Nothing is in production yet, and we were confirmed about it also from Gartner that nobody has anything valuable in production. We are going to change it, hopefully. For developers, there is a most popular project called AutoGPT, which seems to be really incredible. Some people are even saying that this is first version of artificial general intelligence. Actually, this is not true, I can assure you. But it's extremely popular, and because that, a lot of building blocks are built by open source communities, specifically, for instance, LangChain, already mentioned by Pavel, or Llama Index, but there are many newcomers in this area. And it's easier and easier for developers to build AI applications. And last but not least, there are also more and more open sourced large language models, which are more and more efficient, and their total cost of ownership is lower and lower. Yeah. So sooner or later, you will be able to run a large language model on your mobile phone or even on Raspberry Pi. And the last thing I would like to mention here is I had to change my strategy how to Google things in this area, because everything is so rapidly changing that if you find some web page which is more than 1 month old, most likely it's deprecated and it doesn't work anymore. Yeah. So what was our discovery path? So in this case, because it's rapidly changing, it's very new, so we started bottom up more. So we uh, inserted a few developers into this activity, and it was driven by developers from bottom up. We reviewed a lot of competitors ours. We read gazillion of articles related to artificial intelligence and so on. You can see some screenshots here, what use cases we identified before we prioritized them. On the right side, you can see our competitors and what they currently offer. I can assure you not much. Most promising opportunities we identify by prioritizing the list of use cases or opportunities are these ones. So the first group, the main one, is something what I call talk to data. So basically nature language query interface to data, but better than what you usually can see currently on the market. No SQL generation, nothing like that, something better, yeah. But you can see here example questions and users would like to ask and would like to get an answer. And you can also see that I'm not using only English language, but also Czech language. It should be multi-language. The second very important use case or opportunity is help me to generate a source code. Again, it was demonstrated a little bit by Pavel before me. In our case, it's a little bit more complicated because we provide a custom query language called MACL, which is basically a simplified version of SQL. And so we are thinking about to provide natural language interface to help developers to build MACL metrics. Another area which is not related directly with the analytics, but to what must happen before. And it was also presented by Pavel, by the way, because this is his area, is basically some kind of SQL transformations. You come to some physical data model, which is a pure mess, and you want to analyze it in business intelligence. And you can't because the data model is a real mess. Yeah. So the idea is teach artificial intelligence how to transform this mess into something meaningful, something what is ready for the analytics, typically some kind of star or snowflake model. And the last group of opportunities, or the opportunity, is talk to API. This is again a little bit specific for good data, but not only for good data. We are trying to propagate a concept which we call headless BI, which basically means that any client, not only our UI application, can connect to the analytics platform. So to be able to do that, you have to have a good set of APIs and SDKs to provide an optimal developer experience. And talking to these APIs and not studying OpenAI specification is the use case here. And what was the result of the discovery? So first of all, we had to learn how to work with these large language models in general. Yeah. So we quickly realized that it's quite easy to operate large language models on premise. This is an interesting use case in, let's say, both ELT and the analytics, because we are working with sensitive data. Yeah. So the idea to send sensitive data to Microsoft, to OpenAI, is not a good idea, at least not in all cases, right? So that's what we wanted to prove, that it's feasible. By the way, tinier and fast large language models are currently coming. They are currently trained in the clouds. So we can expect that the performance issues coming from operating in on-premise will be sooner or later solved. With the commodity hardware, you will be able to do it on-premise. The second thing we proved is that we can quite easily train, or fine-tune is maybe more correct word, large language models with the proprietary data to prevent it from hallucinations. Yeah, this is really important. Most important is to learn how to structure the data for training or fine-tuning, which means in what form you want to put these proprietary data to large language models, so the answers are correct. Yeah. So usually you use some principles like generating a lot of questions answers, or you generate intentionally wrong answers. Yeah. And you fill in as many examples as possible, and then the percentage of the hallucinations is really near to zero. Yeah. There is one specific use case, by the way, which is called system prompt. This is a property you can send to OpenAI API too. And the system prompt has much higher priority than anything else which is already stored in large language model. So in our case, for instance, basic large language models, even what is currently in ChatGPT, it's trained by our public documentation, good data documentation. There are many versions of good data public documentations. There are multiple versions of our platforms. There is large history. Yeah. So when you ask about anything related to good data, it hallucinates a lot. Yeah. So we had to put into this large language model very specific system prompt, prioritizing the custom data which were injected by training from what is already in large language model. And maybe last comment on this, and this relates to performance and the costs. So you can generate longer and longer prompts to get better answers, but sooner or later you hit the limits, yeah, like 4K tokens, 16K tokens, and so on. So in such a case, there is no other way than to fine-tune the model itself and create a new model. Or you can store the embeddings in vector databases like it was mentioned by Pavel. And then you can send much smaller prompt because the data were injected into the model or into the vector database. Last word, training and prompting large language models is like teaching small kids. Yeah. They are not that smart. They don't have the history, a long history of teaching, learning. So my take on this is that being a good teacher is the profession of the future. Yeah? Whoever will be able to teach either kids or AIs, large language models, will be rewarded in the future. Okay, this is an example of system prompt. This is actually a part of a solution which is currently deployed in our closed beta on production, and it relates to report executions. Yeah, so you are here we are here teaching a large language model how to let's say construct report internal good data report definitions from the natural language queries. Yeah. Interesting thing here is that we specify here the current date. Any idea why we specify current date here? Any clue? Anyone? Exactly. You can specify relative date filters like what happened last week and so on, and you need to know the current date so the large language model can construct the correct filter specification. And this is a second example. This is a standard text prompt you can send to OpenAI or any other large language model. This is more specific. This is quite a new feature of not only OpenAI. You can teach large language models not by text but by definitions of functions. Yeah. So you can tell the large language model, here is a function. Somehow that there is some kind of description. Also, each input parameter is documented here. And then when you ask a question with natural language and you use the type of integration functions, OpenAI or the large language model can answer with the correct definition of the function, which is exactly what we need and every other software vendor will need in the future, because you need this always when you want to transform large natural language into some function. Okay. Okay. So regarding Toll2 data. So we implemented a couple of applications, prototype applications. I would like to emphasize that we are still talking about POC in the area of Toll2 data. So first of all, we try to implement a way how to allow users to explain inside data or report results data. Yeah. The second, we would like to allow users to ask any custom questions about what they can see in report results. And the final use case we wanted to implement and we implemented successfully is the generation of the report itself. We implemented applications using our Good Data JavaScript UI SDK and also Streamlit, and also we implemented an interface into Jupyter Notebook. Thanks to our SDKs, it doesn't matter much. It doesn't bring any additional complexity in the development, because with these SDKs, you can collect the data and interact with OpenAI in a very similar way. In the area of generating source code, I implemented a simple, very simple way how to get our metrics, Muckle metrics from large language models. And in the area of SQL, I tried to implement a POC to ask large language models to generate me SQL transformations from any model to star model. I will show a demo in a second. And in the area of Talk to API, actually, in this area, it's a huge benefit when you already have an open API specification, including a good documentation. I would like to emphasize that, because with bad documentation, you have many hallucinations. So I trained large language model with this specification. I described all our APIs and I failed, because there is a limit in OpenAI allowing you to train only 128 functions, and we have more APIs. So I finally fall back to only get APIs, and I omitted write APIs to fit into this limit, but it works. Okay, so live demo. Let's stop talking and show something real. Actually, yeah, that wasn't necessary. Yeah, so this is a most simple demo you can create when you prototype in the beginning. Yeah. At least in my case, and I believe that in the case of anyone who knows how to program in Python, at least basic knowledge of Python is necessary here. So the easiest way is to create a Streamlit application, yeah, because all the building blocks are already a part of Streamlit ecosystem. So this is a Streamlit application, and thanks to our SDK, you can easily inject things like workspaces for multi-tenancy, agents, and obviously you can collect available AI model, large language models from OpenAI. You can also collect information about what reports or insights you have. You can preview the data, and you can ask questions like, between which years did the number of flights increase the most, by how much, and answer with complete sentence. Yeah, because we want to prevent OpenAI to return only the numbers. Yeah, but we need some explanation. It was fast, wasn't it? Because it's cached. Yeah. It would take much longer, roughly 10 seconds, to generate the answer without the cache. So this is one example. The second example is the SQL example. I prepared some data model for it. It will take roughly 30 seconds to generate it because the prompt is quite huge and it's not optimized in any way because it's a result of discovery. It's just a prototype. But the result is surprisingly efficient, as you will see in a few seconds, and even more seconds. Come on. Don't let me wait. So the original model consists of a few fact tables, but I want to have a star model with all the dimensions and all the dimension hierarchies. And surprisingly, the suggested dimensions contains columns which have something in common. Yeah. So you have, for example, columns customer ID, customer name, and customer age. So the dimension for them is created. And then you have columns loan type and loan type name, and they are also collected into a single dimension. It just shows a principle. Yeah. With a messy data model, it wouldn't work that efficiently, obviously. On the other hand, I didn't prompt it in any special way. So I believe, and maybe Pavel can correct me, with better training, better prompting, it would work even with more messy models. And we are not talking about that you get 100% accurate answer. We are talking about that it will save you, let's say, 80% of your time. So that's the SQL transformation. The report execution, let me try to do something. Maybe it will fail. So let's calculate, I don't know what. So number of flights per, I don't know, FAA region. And we will see what will happen. It wasn't cached, so it will take some time, and it will generate a bar chart. Yeah, very simple. Yeah, and not beautified. Yeah. But it works with all the entities. In this here, I would like to emphasize one thing. Yeah. You can directly work with entities in your database, meaning tables and columns, very often with very cryptic names. Yeah. Or the second option is to build some kind of semantic model on top of this database physical relational model. And you can describe columns and tables with business meanings, with some even more rich description. And if you do this, it will bring you a benefit in this case as well. Yeah, because you can train with these business descriptions, this large language model, and the answers are much more accurate than when you just put the cryptic column names and table names to a large language model, and it will start hallucinate basically. Okay, so let's speed up a little bit. So API execution. So I want to see metrics related to flight. Yeah. So what will happen under the hood? I trained the large language model about our API, so it knows that we have endpoints for metrics, attributes, reports, dashboards, and whatever. So it can point me from the nature language query, it can point me to the correct API. And not only this, but it can also create a specific filter to this API call. So only metrics related to some word are collected. Simple. And the last example is Muckle, our proprietary language. So give me whatever, or let's ask in the Czech language, so not everyone understands. So dej mi sumu počtu flightů, které obsahují good. I have no idea if it will fail or not. Yeah. Actually, it didn't fail. And the result is select some metric flight count that's correct, where label flight num like good. This is not correct. Okay. So the filter entity, the flight num was chosen wrongly. But again, this wasn't fine-tuned in any special way. I'm pretty sure that with some care it would work accurately. Just for demonstration. And the last thing I want to demonstrate here is something what is almost a part of our Good Data platform already. And well, it was somehow reloaded. Okay. So let's try it again. And is Andy still here? No. Is here. So I have someone to punish because it's actually his job. It was developed mainly by Andy. So you can ask about any details in the end if you bring him a beer. So again, chat experience, but it's an integral part of our platform. You can see our dashboard here, and there are metrics like net sales and so on. So give me net sales. So there is type ahead by product, I don't know, category. It should be faster than my demos most of the time, depending on. So this is the result in a text form, but I want, or let's say, chci column chart. Unfortunately, yeah, okay. So it's I need to enlarge it. It's still okay. It's too big, you know. But this is column chart. Interesting use case is that you can iterate. For instance, now at gross profit at, let's say, I will be more specific, at metric gross profit. and it's there, yeah. And now let's filter it to this year, or let's say last year. And it's filtered by last year. The numbers are different, you have to believe me. But you can always check what exactly happened and if the result of the AI was correct, or not the result, but the way, yeah, to the result, yeah. So we always explain what metrics we used, what dimension was used, what filter was used, so you can always verify that it's correct, yeah. This is extremely important, I think, yeah. And you can ask even completely unrelated questions like how many people are attending today's GoodMeetup. Yeah, we will see what will happen. Hopefully not error. And there are 20 people attending today's GoodMeetup. That's interesting, right? How it is possible? So let's explain it. So what was the way? So it counted total number of customers because people are customers, right? And dimension was customer ID. That's completely incorrect. And there is some very strange date filter. So complete hallucination. Yeah. But because you have explained, you can understand why. Yeah. Okay. So let's get back to the presentation. So what's next? Just briefly. Where we target in the near or midterm future. So even more complex use case than generating reports is to generate the whole dashboards, or let's call it stories, yeah. Because LLM can not only generate insights or visualizations itself, but it can also generate the text explanation, a story, which is behind the whole dashboard, yeah. For the inspiration, I recommend you to check the demo from Microsoft with the project LIDA, and it's really good for inspiration. Yeah, you can see there not only the generated story, but the whole way which happened before this story was generated. The explanation, what were the key drivers to these insights, and how this insight was built, and you can override how it was built, and so on. The next thing where we wanna, and we actually already are working on, is combine the AI with other advanced use cases, specifically with machine learning and with something what is called by Gartner key driver analysis, which basically means that you have an insight, there are some data, and you want to know why, what contributed most to this data point, which attributes or which dimensions and how exactly. Yeah. And again, you can trigger this key driver analysis by natural language, for instance. Yeah. The third thing is to optimize TCO. This is obvious in the area of AI. It's too expensive to run on-premise large language models with all the GPUs and so on. So the solution here are tiny models, which are currently created. Better training, so it's more focused on a specific area. Better hardware. NVIDIA plans to introduce new GPUs focused on AI. Yeah. And last but not least, something what is called GPT caching. You can obviously cache natural language queries and their results, but this is not accurate. Instead, you can cache them semantically. So when you ask a similar question semantically, the same cache is reused. Yeah. And last, prevent hallucinations. That's again obvious topic. Again, the solution is optimized training, but also, and it was in my demo as well. maybe it should be with red color, yeah. And it's also part of ChatGPT. You have to inform end users that the results may not be accurate, yeah. I had at least one meeting regarding this with our compliance team, yeah. And last but not least, a new area is currently appearing, and I would call it personally multi-agent, multi-step systems. In the summer, we attended AI hackathon, one building from here, and the company Good AI was presenting a demo for that. What is it about? So you train many agents for very specific tasks, very narrow focus tasks, and then you train a guardian agent who can analyze more complex requests and split them to atomic requests, which can be resolved by these specific agents. If you do this kind of complexity, if you implement something that robust, obviously it should prevent hallucinations a lot. Yeah, and you can also absorb the result. Yeah, when, for instance, the example I showed you explaining the data, it's powered by Pandas AI library, and this is exactly a real agent, which can not only get the first answer, but if the first answer is not exactly correct, or if it is some kind of known error, it can reformulate the question automatically without end user and get the better answer in the second, third, and up to 10th step. Okay, and in general, last slide. So our VP of product strategy, I won't name him, is saying something like this. Yeah. So any company that doesn't adopt AI throughout its organization will become irrelevant in 1 or 2 years. Yeah. And this is not only about talking to data or whatever from the area of analytics and BI. This is about the whole organization and how it works. So in our case, we are thinking about the developer velocity with GitHub Copilot and similar solutions. For everyone's velocity, ChatGPT, we recently introduced internal paper exactly describing what you can do and what you can't do with ChatGPT from the compliance point of view. You can automate infrastructure pieces a lot. Yeah. I also worked in the infrastructure. The level of automation in the current infrastructure is enormous. But imagine that you power it by AI. Yeah, the productivity would be even much bigger. And even for business purposes, yes. Like for example, generate and evaluate campaigns is a good example, and there are open source projects for that already. Or evaluate product feedback. That's exactly what Product Board is trying to do. Yeah, segment the product feedback, for instance. Yeah. So in the whole organization. And the last and really last slide. So we shouldn't be afraid of being replaced by AI. Yeah, we have to learn how to teach these systems, and no one else can do it for us. And still, so many people can't define what they need. Yeah, even product managers and product owners can't do that. So we are safe, and that's all. Thank you. Yes.
Thank you very much, Jacek. Now moving on to the. Wait, hold on. Yeah, I'm sorry, my notebook died somehow. So I'll ask the questions from my mobile phone. I'm very sorry. If you want to see all the questions that are there, you have to use your QR code right there. I'm very sorry about that. And the first question is, what is the most complex muckle you were able to correctly generate using techniques showed in this presentation?
That's from you. He was the biggest muckle expert in good data before he left, by the way. So no, this demo is extremely simple. It can generate simple aggregation functions on top of metrics or facts. It can generate filter, and it can generate for previous pattern, like show me count of flights 3 years ago, and it will generate the for previous syntax, and nothing more. I just wanted to prove that it can work with a few of use cases. Once I will train it with much more use cases and it still will work, I will ping you.
Okay, next one is, what kind of challenges did you have setting it up for multiple languages, like English, Czech, etc.?
Actually, no effort at all was required from me. I was really surprised how efficient it is, at least in English and in the Czech language, and a little bit in German, but I don't know German much anymore. And I was even more surprised that it works with speech to text as well. Actually, the demo currently doesn't contain it because Andy had to redesign it, and the microphone is not there accidentally, but it will be there very soon. I tested it with my natural language in English and in the Czech, and the accuracy was incredible. So, and we didn't need to train it anyhow or somehow specifically configure it anyhow.
Okay, thanks. And last question is, can you directly add the created column chart from demo to the dashboard?
Okay, so this is the question for productization phase. But yes, even now there is a button allowing you to save the visualization as a new visualization, and you can then work with that with drag and drop experience, which already exists in Good Data. And the other obvious interactions with dashboards, applications, and so on will be there once we productize it, but it's not there yet, obviously.
Okay, thank you very much.
Okay. So thank you. That's all from my side. And now we need to solve this issue as well as this issue. I think this is also running out of battery. No?
No, there are two.
Okay, great.
Thank you. And we will continue in 5 minutes. And in case you're hungry, there's some food right out these glass doors. And yeah, see you in 5 minutes for Martin's presentation. Okay, everyone, let's get back for the last presentation from Martin Šmejrek. Just before his presentation, let me introduce him. He worked at the IBM, and currently he's the head of research at Telma AI and is the co-founder and VP at the Mama AI. And his presentation will be about natural language querying. And yeah, here goes to Martin.
So I hope I'm sharing my screen properly right now. So so first of all, thank you very much that you have stayed here. It's dark out there, and I'm keeping you from beer. I came up with the title "Natural Language Interface to Everything," but at the end of the day, from my talk, you might have an impression that there were like 3 speakers today with different training, with different careers, and all of them ended up drafting prompts for ChatGPT, training local llama models, and playing with LangChain. So that's actually true, but maybe only partially true. So I will start with introduction of the Mama AI and how it is with our relation to IBM. So some of us met in the late 90s. Most of us met like 20 years ago in IBM. We started as IBM Speech Group. So in the 90s, we worked on the basic technologies of speech recognition, signal processing, speech synthesis. Then in 2014, we started IBM Watson lab here in Prague after being involved in the Watson Jeopardy project as well. But in 2021, we decided to go on our own and to make a living out of what we have learned in AI. My personal story is that I joined IBM in 2004 and I started working on machine translation. I was in New York, in Yorktown Heights, and I was developing a device for the US Marines, the device that could translate between English and Iraqi Arabic and Pashto and Dari. So basically, it was a communication between people. And, you know, the fascination with language also made it to the name of Mama, because one explanation could be man as in mankind and machine communication. So we do many things. We do many projects on how to introduce AI to different businesses. And for those from those successful projects, we tend to make projects. And here is our mental map of different AIs that we do. So here is like communication AI. You know all of them, voice bots and chat bots. It became very popular these days. We do them in text form, in spoken form, in the segment of telephony, omnichannel, you name it. Then we have search intelligence, where Pavel would call it vector store, for example. So yes, we all use the same technology, vectorized representation of semantic space. So we do search AI, but not only on top of, let's say, structured and unstructured documents. We also do it on in the chemical space of molecules, where we find molecules with similar properties, try to predict their properties that could have some impact on drug discovery, such as things whether they can dissolve in fats or water, whether they will be toxic, things like that. We do personalized AI, which is like generative AI for creating personalized messages, videos, learning materials in different segments like HR, technical, military, things like that. We do metaverse and virtual reality, where again we come from the speech field, so we believe that the speech channel can be very much helpful in virtual reality. We do data science, reasoning, predictive maintenance, anomaly detection, and also we have blockchain product for detecting malicious smart contracts. So we are active in many fields, and today I have picked, and I was instructed to say something about long chains and large language models, and I'm the third person on this stage. So I will try to make it faster and probably go quickly through the demos, because we probably have the same opinion on the technology. It's now all about the question of finding the right use case, doing successful POC, and prove it that AI and large language models and how they will be beneficial for the industry. So let's start with our product called mSearch, which is technically quite similar, or basically the technology built on the same background as vector search. So now what it does, a business, imagine that you have some company database, like knowledge base of documents of different kinds. Here, for the purposes of demo, I can try like English news, and it's a very quick search. In a fraction of a second, I can sift through a database of tens of thousands of text, and I can ask, did any usage food, did any unsafe, I should ask unsafe, probably, unsafe food enter the market? And of course, I get relevant documents from the newswire that contain information about unsafe food. And I can ask GPT to summarize it, right? Because nobody actually wants to read all those documents. And I learn about shellfish products shipped from South Korea, etc. So I can quickly search interesting details from the news. It is multilingual, so if I switch it to Czech, I have some explanation here. I can find some information about unsafe food in British supermarkets and get it summarized here in this section, right? If I ask on German data, I can get salmonellen in Schinken. So you see that if I ask this way, the world seems to be very unsafe place and very risky to live in. Now, but how can this make a benefit for your company? So imagine that you are, let's say, an insurance company, and you have customers. You are facing the customers with their real questions. So I can ask, I lost my golf clubs on the way to a tournament. I have sport insurance. Can I get reimbursement? Right, probably some typos. Let's see if I get something. So in the Czech terms and conditions, we have find some relevant questions and answers, and get relevant answer. Yes, if you have sport insurance, your lost golf clubs should be covered as long as they are within the insured value. And it gets from the documents that the limit value is 50,000 crowns. So this is some example of POC of that allows quick communication and exact communication with customers. Then, wow, then I have yet another example of how long chains can generate SQL codes or data frame queries. So here I have this notorious example of Titanic passenger list, and I can generate quite surprising sociological insights. Such as what is the survival chance for passenger classes, and I learn things that are pretty disturbing. First class 60%, second class 40%, third class 20%. So you don't have to learn all these things to be able to find relations and find interesting insights from the data. Okay, so this was an example when your data is structured. But let's go back to the mSearch and to another successful, let's say, business implementation. And this is semantic search applied to help desk ticketing system, right? So you have let's say a bank that has a large help desk. You have hundreds of operators of that help desk, and they are using, let's say, ServiceNow ticketing system. And so the intuition is that if an employee works on a ticket, you have hundreds of similar tickets that were solved before and probably contain the solution, right? So one of the successful business application of our semantic search and some subsequent large language model agent is to find the most similar help desk ticket and propose solution based on that. So basically, in that scenario, we measure that in 87% of cases we suggest relevant case for the help desk ticket and propose a relevant solution. Okay, so this was the Titanic. Now, these were the tools that give you insight into your data, allow you to search through data. But now here is the other part. If you have some information, how can you communicate it to the people? Here I have some demos that are sorted maybe from the simplest one to more complicated. Let's make it a little bigger. So I guess. No, I cannot make it bigger, sorry. So small businesses, such as hotels, right? Many of them want 24/7 communication with their customer. So here is our Pelma chatbot that can be constructed based on structured or unstructured information that you provide about your business. So here is, what is the name of the hotel, how many stars you have, what's the contact address, when does your reception desk opens, ends, and here you have a chatbot that basically can serve your customers pretty efficiently. And I'm trying to make a PowerPoint slide, communicate with and be interactive. I got a problem too, because I have to move this toolbar. Sorry about that. Here I can actually type. So I have a family of 4. What do you recommend, right? And I get some recommendation for a suite of 2 bathrooms, apartment, etc. And if I arrive around midnight and need a haircut in the morning, so it will probably suggest me that the reception is 24/7 and that I can get a haircut from 8 to 2, because that's when the hairdressers are open. So this is a simple case of simple chatbot that can be quickly created just based on the information found on your website. Then here is another example. Here is our collaboration with the Czech Army, where we try to recruit people to the army. And again, it is the army. So for certain questions, some responses need to be granted. So for more complicated questions, we integrate the chatbot with semantic search and find relevant document based on semantic search. So if I ask ahoy, there will be some basic chit chat. I guess I will have to refresh the page. Sorry. So you see that the interaction is very quick. I need to speak Czech to it. Máte volné pozice. It will. You see that here is the quick interaction based on intent recognition used for dialogue planning. But I can also speak to it in human voice. I can say, jsem programátor, and we will see if...
Prohledal jsem pozice a tyto se mi jeví jako nejrelevantnější. Důstojník, mladší technik. Pokud vás některá z pozic zaujala, neváhejte a klikněte na více.
So based on the semantic similarity, it will search through the current database of open positions and find something from the where my programming skills will be will be like rewarded, and bank, and I am drafted, right? So, or if I ask jaká je výplata, again there will be some LangChain agent behind this, and it will bring me the most relevant pages with that describe the salary. Another use case is in production line, right? You are working on the belt, or you are a manager of a shift, and let's say that you are creating, well, here it is about tightening screws. So you are basically measuring the momentum of those tightened screws, and there is some anomaly detection. Some value is here out of limits, and it generates some alarm, some what is it? Anomaly is detected. So it tells me there is some suspicious curve. The slope top parameter is unusually big. So I can ask, give me the torque curve, right? And okay, I guess I have to restart the connection because it did not stay 60 minutes. So give me the torque curve, right? And it will play with the OpenAPI specification of the database, generate the queries, and the dashboard will basically present the right curve so that I can inspect them. I can do zoom to the top. This actually makes sense, especially if you are having hands full of various tools, and you can communicate with it also by spoken language, right? So here you get a zoom to the very end of the curve, and you can do something like, give me some past curves for the reference, and basically you can control this complicated dashboard just with natural language, and you can inspect that this suspicious curve is slightly different than the other one, because basically the plateau is not flat, it's just going up. So you can say this looks pathological. This is the lingo of the company, right? The plateau is not wide enough, and basically the LangChain detects that the anomaly was resolved. It will make a conclusion that this is actually a bad curve, bad tightening of the bolt, and it will create some JSON message and logs it into the system. So this is another use case where we try to make LangChains and large language models helpful in the business process. So that's, I guess, all from the part of the communication AI. Now, I mean, language interfaces to and text interfaces to different modalities. Now, another segment where this can be helpful is if you have some information and you either want to collect information from people or give them some notification so that they pay attention to that notification. So here is an example of our collaboration with a pharmaceutical company about about when they do clinical studies. So they check whether people take medications and do some statistics about it. So let me play you some example how a conversation in spoken modality can look like.
den, paní Závěrková.
Dobrý
Tady
den.
je váš digitální pečovatel Tomáš. Jaký jste dnes měla den?
No, hodně horký, ale šlo to.
Dobře, to jsou pro mě důležité informace. Trápilo vás dnes něco na vašem zdraví?
No, špatně se mi dýchalo.
Děkuji, že mi takové věci říkáte, moc si toho vážím. Vzala jste si dnes léky, které si každý den berete?
Ano, vzala.
Výborně, tak to je dobře. Zavolám vám zase zítra, abych se ujistil, že se vám dobře vede. Děkuji vám, paní Závěrková, a přeji hezký den.
Taky tak, Tomášku.
So you can see that after a couple of calls, people even built like human relationships with our voice bot. They call him Tomášku. Tomáš is the name of our artificial voice, but it's also the name of the virtual person that basically checks elderly people whether they take medication. One more example where we integrate spoken dialogue with some business. For example, if you want a new connection from Petrininet, it's an internet provider, you can just call there, dictate, it will ask you for your address, translates it to Ruyan code, and finds in the database whether there is optical cables or something slower. So it will directly give you a quote. I will just quickly skip to the part where you dictate the address.
Abych ověřil dostupnost našich služeb, potřebuji znát vaši adresu. Nyní mi prosím nadiktujte adresu místa připojení včetně města. Pobřežní 21 Praha 8. Výborně. Do své databáze jsem si uložil následující adresu. Město Praha, ulice Pobřežní s číslem popisným 665 a s číslem orientačním 21. Je to v pořádku? Ano. Strpení prosím, projdu svoji aktuální databázi. Na této adrese vám nabídneme internet na telefonní síti našeho smluvního partnera s tarify od 490 Kč měsíčně a rychlostí připojení do 100 megabitů se smlouvou bez...
So you can see a lead was generated, and a couple of hours later, a businessman will call that person and signs the contract. So that's another use case. Here is an example of our collaboration with eShop, where we call people who have ordered packages to local stores and they did not pick it up, because that's something where the retailer has to pay like 100 crowns for each package to put it back on shelf. So here is an example of outbound campaign where we called like thousands people a day to remind them to pick up that parcel, to prolong the period till it's sent back. And this actually has a very quick return of investment below 1 month, just because we have shaved off that portion of unpicked up picked up parcels. So here you can see how the campaign goes. Maybe later, or if we have internet connection, and maybe not. Oh, it's going. So the green calls are finished calls, people who picked up and responding something meaningful. You can see that about 1/2 of people will decline the call if you call them. So after a time, you can repeat the campaign and try it for the second time. It just depends on how you configure your meta parameters. But this is an example of a large scale massive campaign. Now the second round is going on, so you can see that we will end up doing around 50 to 50 or more than that of successful calls. So this is an example of our Telma outbound campaign. It's very easy to script your own outbound call campaign. It's also integrated with GPT, so the conversations can be very very fluent. Okay, the last thing that I will show is just an example of our text to speech product and voice. Maybe that you have noticed that a couple of months ago we have built together with Seznam a robotic moderator where especially in the night hours, there is a robotic moderator called Hachiko, which has, and she has very natural voice. Actually, here on the web on the there was a questionnaire where people voted and tried to guess which of the two voices, the natural one and the synthetic one, was the robotic one, and they actually got it the other way around. So let's say the statistical significance, or it was very difficult to guess it. I will play you both examples.
Na webu pro ženy.cz najdete tento týden zajímavý článek, který se věnuje 5 slavným vůním.
So that was sample A.
Na webu pro ženy.cz najdete tento týden zajímavý článek, který se věnuje 5 slavným vůním.
So it's really difficult to distinguish that, and here the difference is that the voices can explain more, can express more emotion, right? The difference is from the typical text to speech voices, where the actors in the studio are instructed to speak like flat sentences so that they can be reused in many contexts. They are instructed to speak without emotions, and we basically built the voice that contains emotion and is really natural. So that's another example of our products that we are working on. So I guess the time is running up, and I think it's about the end of the slot. So thank you very much for your attention, and if you have questions, please ask them.
Thank you very much for the presentation. And now let's jump straight to the questions. Let me just share my screen real quick. Okay, so first question is, what is your favorite Mama AI project?
Well, all of them are favorite, and Honza Vystrčil is here, so I cannot tell, right? But we have, the reason why we left the big corporation and started Mama AI is to have fun. So, and we are having fun, I guess, quite a lot. So I will not answer.
Okay, so next one is, how hard is it to collaborate with the army?
It is. I must say that the collaboration was very, very good. I mean, there were like rules, but what I was surprised that if any date was promised, it actually happened to that date. So it's a positive experience, and also as IBMers, we have a long history of successful collaboration with the army from back in IBM times. So I guess we were not surprised. We basically saw what we expected.
Thank you. And since you're the last, we have 2 more questions. And so, does somebody check the answers like difficult breathing from the medical point of view to prevent potential health issues?
Well, currently in this demo we don't, but there are things that we check, and what we maybe in other scenarios we can detect emotions of the person, either of the operator or of the customer. That's, for example, useful in help centers so that you can detect problematic calls, like where people are exciting and yelling at each other. Another thing, we detect cadency. So and it's actually, and we modify the speed of our text to speech to the cadency of the customer, because it actually improves the success rate of the collaboration. So it's good to match those speeds. We can get with reliable accuracy the sex of the person. What else? We can get with the precision to the decade. We can classify the age of the speaker. So these are the things that are that we currently extract from the spoken signal. We have read papers about detecting breathing problem or even COVID problems from the speech. So this can be done with certain precision.
Thank you. And the last one is, in which area do you see the greatest potential for growth?
Well, currently, as you have seen it, we are all playing with local language models. We are playing with the large GPTs. We are playing with lang chains. We are trying to build agents for whatever practical tasks, and we are all in search of the of the of a successful POC application, right? So that's where we currently invest a lot of time and where we believe there will be a breakthrough. So you have seen the examples that we are trying, and that's where we have our bets on.
Okay. Thank you very much for your presentation, and a round of applause, please, for Martin.
Thank you.
Okay, so thank you everyone for coming. Thank you everyone for joining through Zoom, and I'll end the meeting now. And for all of the others who are staying here, please stay here. We still have food. Let's talk over beer. Thank you.